He said, go. Okay. Quadrilaterals. We finished half of Unit 8 last week, geometry section. Now we're going to talk some more about our geometry section. And we'll go over some things we've already gone over the first time we talked about geometry this year. If you remember, a couple months ago we did geometry and we did square, rectangle, parallelogram, trapezoid, because we did finding the perimeter and area. We did the perimeter and area. Well, today we're just going to talk about classifying these guys and some interesting things about their angles. So, let's quick review. What is a quadrilateral? Four-sided figure. Four-sided figure. This should be a quick review. It's already in our notes. We're putting them in again, so we won't have to look so far to find it. All right. How would we describe a square? Four. Now we don't say equal in geometry. We're fancy. Four congruent sides. Four right angles. Now I'm abbreviating. Four equal sides, four congruent sides, four right angles. Now draw one like we did several weeks ago. What do we put in the corners or the vertices? Those boxes represent what? 90 degrees, right angles. So we put boxes there. Now what did we put on the sides to denote equal or congruent sides? Slashes. Dashes, slashes, lines. I call them slashes. Slash, slash, slash. All single slashes, meaning they're all equal. Birthday girl's tired. She's young. I got candy back there for you in a little while. Don't let me forget. All right. Rectangle. Opposite sides. Congruent and also four right angles. And of course, draw the picture. Now I didn't say anything about the square sides being parallel. We assume that, don't we? Now in a rectangle, what do we put in the vertices, corners? Boxes that represent right angle, which represents 90 degrees. There we go. Now, what about the sides?
The one line, and two lines.
Slash, slash, and what were you saying, Bryce?
Yeah, slash, slash, and then two slashes.
Oh, why can I not single slash this up here now?
Because that means it's equal.
They're different than the single slashes, so I have to put a double slash to denote a different length, but it's equal to the other double slash. Right? All right. Parallelogram. Well, that sounds familiar, doesn't it? It's the same as a rectangle. So what changes, though, for a parallelogram that it's not in a rectangle?
Rectangle can be a square.
No.
The angle. Doesn't have right angles?
Does not have right angles. But what do we know about the angles of a parallelogram?
Two obtuse.
Two obtuse, two acute, but what can I put up here?
No.
What about them? I'm not going to put no right angle. Oh, hang on. Dakota, opposite angles, congruent. They're opposite each other, they equal. But they're not the same. They're not all the same. They're not all 90 degrees. So, that's not very good. Gotta get it to where it kind of looks halfway like the other side. There we go. Now, can I put single slash, double, double?
No.
Yes, just leave it.
Oh, yeah.
Okay. Now, what about the angles? No, not boxes. Boxes mean 90 degrees. I call them swooshes. Single swoosh, opposite it, single swoosh. What do you think about the others? Double swoosh. Because if I single swoosh, that means they equal all the other single swooshes. It's not the case here. These two are single, these two are double, meaning opposites equal, other opposites equal. Ah, we did a trapezoid several weeks ago. One set of sides. Y'all understand that's not 11, right? That symbol is not 11. That's our parallel symbol, okay? First period went 11. I went, no, that's not an 11. My 11s are shorter than that. Parallel sides. One set of parallel sides. The other sides, however you want to put them. We likened it to a plateau. And we showed parallel by putting what, y'all? An arrow, right? Showing that's the parallel side. Now, remember how a trapezoid can also have a perpendicular side, straight up and down side, chopped off. Still a trapezoid because it still has only one set of parallel sides. One set. Rhombus. I don't think we did this one. We didn't do a rhombus several weeks ago, so this one should be new. You know what it is from last year. Rhombus. Four congruent sides.
Squash square.
Opposite sides. Right? Opposite angles congruent or equal. And Ron, you were saying it's a what? Is that, Ron, were you saying it?
Yeah. Squash square.
A squashed square. Now this one's hard to draw because it's hard to get it squashed and have all the sides be the same length. So I'll do the best I can. But it's very hard to do.
Just turn your head and make a square.
That'll be a square.
No, what if it looks different?
Oh, well, that's about the best I can do. Single slash, single slash, single slash. Now, what about the vertices, the angles? One swoosh, double swoosh, double swoosh. All right. In the past, and I have found that elementary teachers are bad about this, and if any of them watch the video, I apologize. But a lot of elementary a lot of elementary teachers call the rhombus a diamond.
Diamond is a round.
Diamonds are not a geometric figure, okay? They may do it to try to help students understand what they look like. If you turn that to where the points are up and down, it does look like the quote-unquote diamond shape. But there's really not a diamond shape. It's a rhombus. The next one also sometimes gets confused as a diamond. It's not. It is a kite. And yes, there is a kite geometric figure. And it's kind of hard to give a definition of it because it might be slightly confusing. I will put it as simple as I can make it. A kite has, well, it's a quad. That automatically tells us what? 4 sides. So it's a quad that has adjacent, J-A-C-E-N-T, parentheses, adjacent. Now I'm going to define real quick what the word adjacent means. Adjacent. It's a quad that has adjacent. Now, Abby, if I live adjacent to you, what does that mean? Next to me. If we live adjacent to each other, we are next door. So I always put the definition of adjacent is next door. Right next to each other. It's right next door to each other. So, a quad, it's a kite, is a quad that has adjacent sides congruent. I don't like that. I'm going to put in parentheses 1 set. No, 2 sets. What a dingle. 2 sets. I apologize. 2 sets of these. Now, draw with me what was going to be an isosceles triangle, but I'm not going to close it in. Isosceles triangle. Then, draw another isosceles triangle going down, but make the sides longer. Everybody with me on that? And now, put a slash, slash on the top ones. Double slash, double slash. The top 2 are adjacent to each other, congruent. The bottom 2 sides adjacent to each other are congruent. Now, I always have some students trying to be smarty britches and say, well, these 2 are adjacent to each other and they're not. I understand that. But I'm saying there's 2 sets of them. You just have to find which 2 are which 2, okay? All right, Ron? Okay? All right. Now, we could say something else about the angles. What do you see about the angles, y'all?
2 cute.
What do you think?
2 cute and 2 cute.
Yeah, but what do you think?
Opposite angles are congruent.
Opposite angles are congruent? Or just 1 set?
Just the same, like type.
There's 2 sets of the same angles.
So you want to say opposite angles congruent? Y'all want to say that? I guess we can say that until we prove it wrong. Okay? And y'all see which ones, right? Swoosh, swoosh, double, double? Or do you just have these being it? Be something to look into, right? Maybe you need to do a little research on that. But that gives us a kite. That is the quadrilaterals we want to look at. So if you're told to classify what a picture looks like, your multiple choice is a square, rectangle, parallelogram, trapezoid, rhombus, kite, or maybe just a plain old quad. If you have a figure that doesn't have these things on it, for instance, this right here, y'all. What would you classify that as? Nope. Okay, let me change it then. There you go. There, now.
Shoot.
Kite.
Nope. Oh, I did do that too. No, I didn't. It's longer. This side's longer than that one. Ha 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 ha. Good try. It's not a square, it's not a rectangle, it's not a parallelogram, it's not a trapezoid, it's not a rhombus, it's not a kite. It's just a plain old quad. It has no fancy classification because it does not match any of these definitions. So when we're told to classify, we look Does it match any of these? If it doesn't match anything, it's just a plain old quad. Everybody okay with that? All right, now let's go on to something else. So we kind of got a dot line. A polygon. Any, many, miny, no. Any many-sided figure. Any many-sided figure. A triangle is a polygon. A quadrilateral is a polygon. An octagon is a polygon. A pentagon.
6. 5.
5 is a polygon. Hexagon.
8.
6.
6. Polygon. Hepta.
7.
7. Nono.
8.
There's just some other ones. We'll go into those later, okay? So a polygon is just a figure that has a lot of sides to it. If we have a regular polygon, many-sided, oh, I forgot my D on many-sided up there, didn't I? Many-sided figure that has all angles congruent and all sides congruent. So, an equilateral triangle is a regular polygon because all its sides equals and all its angles equal. Trying to draw one, but it's hard to. Where slash, 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 and swoosh, 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 swoosh. How many sides?
How many polys?
1, 2, 3, 4, 5, 6, 7, 8. So this is a octagon, and since all the sides equal and all the angles equal, this is called a regular octagon. Regular meaning all angles equal, all sides equal. Okay? You okay with that? All right, 2 more things. What's wrong, Holmes?
Would a square be
A square is a regular polygon. Okay? Very good. Triple stars. This is just like triple star from triangles the other day. Here you go. So if you've left me, please come back. Tough Monday, I understand. In a quad. What's that? Quadrilateral. All the angles add up to 360. Now, guess what students confuse this with? 180. Because last week we added all the angles of a triangle and they were supposed to be 180. And now we have a quad, and if we add up all 4 vertices or 4 angles of a quad, it's supposed to equal 360. Triangle, 180. Quad, 360. I'm trying to make you concrete it in your brain. You have to repeat it to yourself. Triangle 180. Quad 360. The easiest way to remember it is 4 angles, that's more, isn't it, than 3 angles. So the 4 angles have to add up to more degrees than the 3 angles. 3 angles, 180. 4 angles, 360. You with me? All right, here we go. Naming figures. You name figures like you name angles. Use the letters from the vertices. And what's the vertices? The angles, the corners. Whew. Quadrilaterals, polygons, and naming them. Quads, polygons, and name them. A little bit about 360. So, looking at our example over here, can you name a triangle in this figure?
Yes, sir.
How many triangles do you see first?
3.
1, 2, 3. So, the one Colton may name may be different than the one Mary names, correct? Depends on which one you pick out. So, I'm going to go with Mary. Mary, pick me out a triangle and let's name it. D.
C.
To C.
E.
To E. Very good. I'm going to put a little triangle symbol, and she said go from D to C to E. Does everybody see the triangle she was talking about? She went from D to C to E. This one. If we're told to name a triangle, pick one out, name it with the vertices, the corners, the angles. Just like we did angles. Now, you don't have to name all 3 of them, but let's name the other ones just to show. Triangle who?
ABC.
A, B, C. He went here to here to here. That one right there. Triangle ABC. What's the last one?
ACE.
ACE. Could I have called it ECA? Could I have called it CAE? Could I have called it CEA? Could have named it several ways, but it's still the same triangle. All right, let's name a trapezoid. Now, before I ever start naming that, I need to remember what it looks like. I need to find something in that picture that either looks like this or looks like this. Christian?
ACDE.
Okay, hang on. Start at A. Now, why'd you name 4 letters?
Because it's a quadrilateral.
It's a quad. Good job. All right, you went from A
C.
to C to D
E.
to E, and of course back to A. Did everybody see his trap? So, I'm going to draw a trapezoid icon and he called it A, C, D to E. Everybody agree? Do you see a second one?
Yes.
Oh, that hurt my elbow. A, B, C, E. What do you think? Is that the other one? A, B, C, E? Okay. Name a rectangle. Everybody better get this one real easy. A, B, C, D.
E.
Ah, A, B, D, E, right? Name the vertices. I put C in there, didn't I? C is halfway down one of the sides. And use it. A, B, D, E. How hard was that?
Easy, hard.
Easy, hard. All right, let's go. Steven? Now comes the tough, I gotta think part. Now comes the tough, I gotta think part. We've got to find the missing vertex. missing angle, the missing corner. All right, look at this first one. Common sense tells me something, Bryce. What? Common sense tells me what?
It's a rectangle.
It's a
And
rectangle.
There's right angles, and it's a quadrilateral, so it's going to go 360.
Very good. So what is x?
90.
X has to be 90 because I've got 3 right angles. That's 270. Take away from all of them, that's
360.
3 stars over there. 360. So what's 360 minus 270? 90. Common sense says right angle, right angle, right angle. Last one has to be right angle. Common sense tells me that. All right, so I can just go straight to 90 degrees. Okay? So, Cody, now, what we got on this one, brother? How are we going to find x when all I've got is 110?
Add 110 in the 2 right angles.
Oh, so you're telling me I got to do some adding and then minus, what am I going to minus from?
360.
360. So I need to do some adding. What did you want to add?
110,
110,
90,
90,
90.
90, because of what?
The 2 right angles.
2 right angles. All right, so here we go, 0, 10 and 9, 19, carry 1, 290. So 360 minus 290. Y'all are upper level. Y'all should do that in your head. 70. So the x is 70 degrees. We all agree with that?
Yes, sir.
All right. Ooh, what did I do on this one to try to jack with your head?
Oh,
What? We got some what?
you made us add up to 180 instead of 360 because it's not a quadrilateral.
It is a quad. You can't see from that far. Hey,
Oh, thanks.
that's my job. Can you not see? You can walk over here and see closer.
I thought it was a triangle.
I know. I got this little top of that triangle cut off. But what did I do to jack with you, though? Abs? Got some decimals in there. We still do it like Cody said over here, though, right?
Pretty much.
We're going to add some stuff, and then what are we going to do?
Subtract.
Subtract from 360. All righty? So what do I have to add?
140.5.
140.5.
80.3.
80.3. Oh, I happen to be lining up my decimals, something we learned first semester.
62.
Uh-oh, where do I put the 62? Like that?
No.
He has a Casper
0.
decimal and 0. So there, 62 and a 0, right? All right, here we go. 8 decimal. 2. Oh, 4 and 8.
18.
Oh, 18. All right, good. Camera 1. 282.8. Where do I put it over here?
Line them up.
I better make Casper show up over here, right? Now I can go 8 point and then a 282. Agree? Woo! All right, here we go. Oh, I can't. 5. 2 decimal. 7. Up. 7.
0.
So what is the missing angle? 77 and 2/10 degrees. Tried to jack with you there, putting some decimals. Now I'm going to make it even harder. Pre-AP class. Now I'm going to make it harder. Oh my goodness. Raina, what is wrong with our first one over there? Over there, over there, over there.
There's 2 and then a little X.
Yeah, we're not talking about just a plain plain old x. We're talking about 2 x's and 2 x's. How do you think we're going to do this?
Times 2. Then multiply times
Add
VA?
130 and 7.
Well, if they're congruent, then they're going to be the same number, so you have to figure out one.
Now, we need to find out, so you're saying they do equal each other, right? Because they're identical, 2x and 2x, so they must be the same thing. What else can we do? There's a possibility they could be right angles and we have a trapezoid looking at us, right? But we're not quite for sure. So Christian was saying something a minute ago.
Add 130 and 70.
Let's add 130, just to look at it, plus 70. What? How much? Exactly 200. Now what is all of them supposed to equal? So 360 minus 200. How much? 160.
Divided by 2.
And it's got to be for 2 angles. So 160 divided by 2 is 80. So that means that whole angle is 80. That whole angle is 80. But we're supposed to find out what is x. This angle is 80, but it's also said to be 2x. Makes 80. 2x has to be that 80 we found. So what is just x?
40.
Okay, only if 2 or 3 saw that. 2 times something gives me 80.
40.
Does everybody see it now? 2 times something's got to give me 80. So just x is 40. Had this, everybody with me on that? Had this been just plain old x, then x would have been what? 80. But that wasn't the case. It's 2 x's make 80. 2 x's make 80. Talk to me.
Can I have Bryce Older, please? He's going to the doctor.
Pick up one of the papers on the way out.
Thank you.
Thank you. All right. That's kind of some deep thinking there, Mr. Pre-AP. This is algebra. Yeah, this is algebra. Oh, cool. All right, now let's look at this one. What's wrong with this one? Still 2 missing. This one doesn't have those 2x and 2x. It's just plain old x. Maybe it's going to be easier. All right. So what do you think we're going to do over there, Parks?
You know the opposite sides are equal, so I can't read the 2 numbers in the thing.
Well, get up and move where you can see them, dude.
Well, those 2 are 80.
80. So what are we going to do?
Add up
So 80 and 80
160.
is 160.
You can tell
We
the
know
difference.
all of them are supposed to be 360. I'm left with 200, but that 200 has to be both of them, for both of them.
Divided by 2.
Divide 200 by 2, so that means this guy's 100, that guy's 100, but we just want to know what is x. Oh, x is 100. That one was actually easier.